all, welcome to once. In this session, power systems transmission line parameters and the topic previous year GATE questions discuss. Okay, so let us begin. First question. A single phase transmission line has two conductors, each of 10 mm radius. These are fixed at a center to center distance of 1 meter in a horizontal plane. Okay, this is now converted to a three-phase transmission line by introducing a third conductor of the same radius. This conductor is fixed at an equal distance d from the two single-phase conductors. The three-phase line is fully transposed. The positive sequence inductance per phase of the three-phase system is to be 5% more than that of the inductance per conductor of the single-phase system. The distance d in meters is. Okay, so the lengthy question ആണ്, പക്ഷെ നമുക്ക് ഇതൊന്ന് അനലൈസ് ചെയ്യാം. അപ്പോൾ നമുക്ക് ഒരു സിംഗിൾ ഫേസ് ടു വയർ ട്രാൻസ്മിഷൻ ലൈൻ ഉണ്ട്, ടു കണ്ടക്ടർ സിസ്റ്റം ആണ് സിംഗിൾ ഫേസ് സിസ്റ്റം. ഓക്കെ, സോ ഓരോ കണ്ടക്ടറിന്റെയും റേഡിയസ് 10 mm ആണ് ക്വസ്റ്റനിൽ സ്പെസിഫൈഡ് ആണ്. എത്രയാണ്? 10 mm. ഓക്കെ, സോ വി ഹാവ് ടു കണ്ടക്ടേഴ്സ്. Okay, conductor A and conductor B. Okay, then each of these has a radius of 10 mm. Okay, 10 mm radius. And center to center distance തന്നിട്ടുണ്ട്. എത്രയാണ്? 1 meter. Center to center distance is given as 1 meter. Horizontal plane ലാണ്. So this is the case 1. Okay. This is case 1. We have a single phase transmission line. Ini idine endana parneyekkunna, it is converted to a three phase transmission line. But case e single phase transmission line ne nammal oru three phase transmission line aayittu convert cheyidal engane convert cheyidal by introducing a third conductor of the same radius. Okay, now if I take case 2, yes, case 2 the system is now changed to a three-phase system. You are introducing a yet another third conductor. These two conductors you are introducing another conductor. Let this be A, let this be B, and let this be C. Okay, how's the third conductor fixed? It is fixed at an equal distance d from the two single phase conductors. But this distance is 1 meter. Third conductor is spaced at d meters from the previous two conductors A and B. Okay, this distance d meters aayittu place cheyidu. Appo idana question la case aayittu tannekkunnathu. And fully transposed three phase system aanennu tannittundu. And it is given a condition is given. In the condition aanu positive sequence inductance per phase of the three-phase system is to be 5% more than that of the inductance per conductor of the single-phase system. But idile positive sequence inductance is 5% inductance in the obtained single-phase inductance per phase inductance obtained in the first case. So idile namukku ee distance d aanu nammal kandupidikkana solve cheyandathu. Okay, appo namukku idine ഒന്ന് ചെയ്തു നോക്കാം എങ്ങനെയാണ്. ഇപ്പൊ ഇൻഡക്ടൻസിന്റെ ഫോർമുല വെച്ചിട്ടാണ് ബേസിക്കലി ഈ ക്വസ്റ്റ്യൻ നമ്മൾ വർക്ക്ഔട്ട് ചെയ്യേണ്ടത്. അപ്പൊ ഫസ്റ്റ് കേസിൽ നമുക്ക് ഇൻഡക്ടൻസ് കണ്ടുപിടിക്കണം. ഇൻഡക്ടൻസ് പെർ ഫേസ്, ദാറ്റ് ഇസ് LA is equal to LB. സിംഗിൾ ഫേസ് ടു വയർ ട്രാൻസ്മിഷൻ സിസ്റ്റത്തിലെ ഇൻഡക്ടൻസിന്റെ ഫോർമുല നിങ്ങൾക്ക് അറിയാലോ. ഇറ്റ് ഇസ് 2 into 10 to the power minus 7 ln D by R dash, right? എന്താണ് യൂണിറ്റ്? ഹെൻറി പെർ മീറ്റർ. സോ ഫസ്റ്റ് കേസിലെ ഇൻഡക്ടൻസ് നമുക്ക് കണ്ടുപിടിക്കാം. എല്ലാം ഗിവൺ ആണ്. ഡിസ്റ്റൻസ് 1 മീറ്റർ ആണെന്ന് തന്നിട്ടുണ്ട്, റേഡിയസ് 10 mm ആണ് തന്നിട്ടുണ്ട്. സോ വിൽ ജസ്റ്റ് ഫൈൻഡ് ഔട്ട് ഫസ്റ്റ് കേസ്. ഓക്കെ, LA is 2 into 10 to the power minus 7 ln distance between the conductor എത്രയാണ്? നമുക്ക് ക്വസ്റ്റ്യനിൽ എത്രയാണ്? 1 meter ആയിട്ടാണ് തന്നേക്കുന്നത്. 1 meter. So I'll convert this into centimeter. Let this be 100 centimeter. 1 meter is 100 centimeter. And radius is given in the question as എത്രയാണ്? Radius നമുക്ക് എത്രയാണ് തന്നേക്കുന്നത്? 10 mm ആണ് തന്നേക്കുന്നത്. Okay. So 10 mm. 10 mm is given. 10 mm is what? 1 centimeter, right? Yes. So you just substitute 2 into 10 to the power minus 7 ln d by r dash ആണ്. Okay. R dash നിങ്ങൾക്ക് അറിയാം 0.7788 r ആണ് അല്ലേ? So d is 1 or 100 centimeter. 100 centimeter by r dash is 0.7788 r. R എത്രയാണ്? 1 centimeter. So I'll replace it as like that itself into 1. Okay. 10 mm ആണ്, that is 1 centimeter. So numerator and denominator unit I converted it into centimeters. So this is this much Henry per meter. So ഇത് നിങ്ങൾക്ക് evaluate ചെയ്ത് കിട്ടുമ്പോൾ you will get the answer as LA is equal to LB. Same inductance per phase of the two-wire single phase two-wire transmission system as 9.71 into 10 to the power minus 7 Henry per meter. Okay, this is same as you convert it to micro Henry per meter ആണെങ്കിൽ 0.97 micro Henry per meter. Okay, so this is your first case answer. Okay, now in the second case, okay, second case, that is case 2, it is given that the per phase inductance will be in the with respect to the three phase conductors will be how much percent more than that of the inductance per conductor of the first case? 5% more than that of the inductance per conductor of the first case. അപ്പോൾ ഇവിടെ നമുക്ക് കിട്ടുന്ന L nu or L nu three phase system for three phase system is how much? 5%. So I can write 1.05 into L initial, that is LA. നമുക്ക് ആദ്യം കിട്ടിയ inductance. Okay. Yes. So I can write L nu second case. Second case, the L nu will be 1.5% more. So 1.05 times LA, the previous value that we have got. So that is the value comes to be 1.05 into 0.97. That is how much? 1.0185 micro Henry per meter. Right? Okay. Now how to actually deduce the inductance per phase in a three-phase system? ഇത് നമുക്ക് inductance per phase of a three-phase systemത്തിലേക്ക് ഈ value equate ചെയ്യണം. Okay. So അതിന്റെ formula നിങ്ങൾക്ക് അറിയാം. Second case, again, L nu is obtained as 2 into 10 to the power minus 7 ln D equivalent. D equivalent എന്ന് പറയുമ്പോൾ you have to take cubic root of all the three distances. അല്ലേ? You have to take the cubic root of all the three distances. ഏതൊക്കെയാ distances? D into D into 1. It is D square into 1 meter or D square into 100 centimeter എന്ന് എഴുതാം. Right? So just write this is D into D into D equivalent ആണ്. അപ്പോൾ D into D into 1 meter or 100 centimeter divided by R dash. R dashന്റെ വാല്യൂ മാറുന്നില്ല, 0.7788 into radius മാറുന്നില്ല. So it is 1 itself, 1 centimeter, right? Henry per meter. Okay, so you just equate the answers like this. So it is 2 into 10 to the power minus 7 ln cubic root of 100 d square divided by 0.7788. This you have to equate it to what? The value points into r, that is 1, is equal to the value equate to equate it to this new value, that is 1.0184 microhenry per meter. 1 microhenry per meter henry per meter convert cheyanam. So standard unit namukku ini convert cheyanam. So it is 1.0185 into 10 to the power minus 6 Henry per meter. Okay, so we have the solving ln cubic root of 100 d square divided by whole bracket under 0.7788 is equal to, you take this 1.0185 into 10 to the power minus 6 by 2 into 10 to the power minus 7. Okay, this you will get it as 5.0925. Okay, so ln some value is equal to 5.095. So this value, this x, let this be x. So this is equal to e to the power 5.05925. So you have cubic root of 100 d square divided by 0.7788 is equal to e to the power 5.05925. E to the power, that value comes to be 162.796. Okay. So this you d solve cheyda madi. Okay, the just multiply. So I'll just write here cubic root of 100 d square is equal to 0.7788 into 162.796, or you will get 100 d square is equal to 126.78 okay, 100 d square, the whole cube. So you'll find d square as 20380.22 and d you will get it as root of 20380.22, that is 142.7 centimeter. Okay, so this is your answer, 142.7 centimeters. But we centimeters ella distances convert either. So answer of D also will be in centimeters. So 142.7 centimeter. So we have just used basic formula for inductance of a transmission line with respect to single phase two-wire system as well as three-phase system. Three-phase we mutual mean distance cubic root of the three equivalent distances. So here it will just d into 100 that equate it is 5% more than the first case. So that equate d the value obtain. Yes? Okay. So this is answer will comes to answer is 142 point numerical type question ana. So 142.7 centimeter. Yes? Okay. Now we'll move on to the second question. So the performance of transmission line na base the question ana. Question number 2. The ABCD constants of a 220 kV line are A is equal to D is equal to 0.94 angle 10 degree, B is equal to 130 angle 73 degree, C is equal to 0.001 angle 90 degree. If the sending end voltage of the line for a given load delivered at nominal voltage is 240 kV, the percentage voltage regulation of the line is. Okay, so ABCD constants line left and the tender. Okay, 220 kV line and A, B, C, D constants namukku question il thannittund. Sending end voltage specified for a given load 240 kV. And this is the 220 kV എന്ന് പറയുമ്പോൾ receiving and full load voltage ആണ്. Okay. So given data നമുക്ക് ഒന്ന് എഴുതാം. So let given the sending end voltage as how much? 240 kV. 240 kV. So this is line voltage. So sending end voltage Vs, let this be Vs per phase. Vs per phase will be how much? This 240 by root 3, right? 240 by root 3 per phase like convert it. Yes. Then next it is given that 220 kV line. 220 kV line means we can assume it as a receiving end voltage. Okay. Receiving end voltage under loaded condition. Receiving end voltage. Receiving end voltage is 220 kV line voltage. And ABCD constants in the equation namukku ariyalo. Relating sending end voltage and receiving end voltage and receiving end current. Endana as we know, okay, Vs is equal to A VR plus VIR. ABCD constants വെച്ചിട്ട് നമ്മൾ short line parameters നമ്മൾ derive ചെയ്തതാണ്. Short line ന്റെ ABCD first equation sending end voltage receiving end voltage receiving end current A B ആയിട്ട് constants ആയിട്ട് rate ചെയ്തേക്കുന്ന equation നമുക്ക് അറിയാം. Okay, so we'll take no load condition. Okay, no load condition. At no load condition, what is IR? There is no current the receiving end, so it is 0. So we have a relation like this. This idellam per phase lana ta, per phase. This is also per phase. At no load, we have Vs per phase. Vs per phase is equal to A VR at per phase no load condition plus 0. Okay, so what is receiving end voltage at no load per phase? We have Vs per phase, okay, Vs per phase by A. This is 0, right? So Vs per phase നമ്മൾ already എഴുതിയിട്ടുണ്ട് 240 by root 3, right? So this is just equate 240 by root 3 divided by A. A endana? A it is given as 0.94 angle 10 degree. So you just need to take the constant. A is equal to D is equal to 0.94 in the edutha madi. Okay. So just write into 0.94. So you'll get the answer as 255.32 kV by root 3. Root 3 ne njan kalayunnilla. Ee factor njan angane enna retain cheyana. So no load receiving end voltage per phase is 255.32 kV per by root 3. So what is the line voltage no load receiving end voltage? VR no load line into root 3 vechu cheytha madi alle. ഞാൻ ഒന്നോടെ സിംപ്ലിഫൈ ചെയ്ത് എഴുതാം. That is no load receiving end voltage line value. Okay, line value, line to line value, that is VR no load okay, is equal to 255.32 kV. √3 വെച്ച് മൾട്ടിപ്ലൈ ചെയ്യാം. ഓക്കെ ഓക്കെ സോ നമ്മളോട് ചോദിച്ചേക്കുന്നത് പെർസെൻറ്റേജ് വോൾട്ടേജ് റെഗുലേഷൻ. വാട്ട് ഇസ് ദ ഇക്വേഷൻ? പെർസെൻറ്റേജ് വോൾട്ടേജ് റെഗുലേഷൻ നമ്മൾ പഠിച്ചാണ് അല്ലേ, പെർഫോമൻസ് ഓഫ് ട്രാൻസ്മിഷൻ ലൈൻ എന്ന സെഷനിൽ. യെസ്, ദിസ് VR no load, that is receiving end voltage at no load, receiving end voltage minus receiving end voltage full load by receiving end voltage full load into 100. That is VR no load എത്ര കിട്ടി? Sorry, 255.32. Okay, 255.32. VR full load is 220. നമ്മൾ ആദ്യം ചെയ്തത് 220 divided by 220 into 100. Okay, so that value you will get it as 16%. Okay, so 5, 9, 16, 21. Option C is the right answer. Okay, so in this session we have just discussed two important problems from the session transmission line parameters. So we'll discuss the other questions in the next session. Thank you.